episode on using the ConceptBase system. My name is Manfred Joisfeld, and today's topic is the answer format. Queries have an answer format which is default, the so-called Taylor's frame, a frame-like representation of the answers, so objects with attributes attached to them. In some cases, you would like to have a specialized answer format, for example, XML like, or comma separated values, or maybe even a textual answer format that is human readable. The answer format feature of ConceptBase uses text pattern replacement, kind of production rules that replace a certain pattern, a variable in a string by some other string, and that process is done until no more patterns shall be replaced. So our first example is a person database. The person have children, or several childs, and we have a simple query here that returns persons with parents. So if a parent has a child, and the child has this person as a parent, so that's how the parent attribute is returned. So if we let's tell that, then we have the definition. Let's tell some example database. So Mary has 2 children, Charlotte has 1 child, Frederick has no child, as well as Albert. Bill has 2 children, and John has no child. So that's a very simple database. Let's ask the query without any specific answer format. So the system proposes here default, which tells the ConceptBase server pick the right answer format for this query, which will be a frame-like representation. So this is the result. So Charlotte has 2 parents, Mary and Bill, and so forth. So that is the answer to this query. Note that the labels here are system generated because the parent attribute is derived. It's a computed attribute. Good. So let's assume we would like to have a textual answer format for that, where we see the result in a more human readable form. And that's this type of definition. So this is the answer format, person format. That's the answer format that we are defining. We may define for which query it is a default answer format. So that is our query person with parents. And the order of the results, it's using the alphanumerical object name for ordering. Then the attribute by which to order, that is here the object name itself. So this stands for the answer object here, like Mary or so. And then in the answer format, you can have a string for the head of the answer. So in general, a query has a set of objects as answer, let's say 3 objects, and it will display the 3 objects in the answer, and at the top there will be a head, a heading, a string. There can also be a tail string. You can also leave out these head and tails. And then the important thing is a pattern. That is the pattern that is used to replace an answer object by this textual string. Now in this pattern you see some elements that has curly brackets, and they are going to be replaced by the current answer object, by the details of the current answer object. So for the first one, then for the second one, then for the third one, and depending on how many answer objects you have. This stands always for the answer object itself, so for the object name of the answer, like Mary or Bill. And then you can, if it has attributes, like computed attributes or retrieved attributes, or later we'll see inherited attributes, then you can refer to their values by this dot syntax. So this dot parent. So that's a very simple answer format. Let's tell that and ask our query again. So person with parents. We could use the default, but now we can also select the person format that we just specified. So if we ask that, we see we have the hat here, and we have 1, 2, 3, 4 answer objects in this case. Albert has one parent in the database, Charlotte. Charlotte has 2 parents, so this dot parent is a multi-valued attribute. So it could be several, then they will be separated by a comma. So that's how the default treatment of attributes is. And then we have Frederick and we have John. So that's a very simple answer format. In the next one, we will deal with the fact that some attributes have multiple values, and we would like to iterate over these values to have some more interesting representation of this, or that we can customize the design. So let's restart. Okay, so the next one is iterations. So it's a slightly different design. We now also have an age attribute, and now parent is the extensional attribute. We don't derive parent from child. We directly say who is a parent of a person. That's a query. We return the parent and the age, the 2 attributes here, and we demand that the age must be greater than 10 in the query. So we can have a query that has a membership constraint, of course. That's the answer format. So here the answer is in an XML-like representation, or HTML-like representation. We have a hat which just declares HTML and then some text, and that we have a numbering of elements, and then we have here these different list elements. This will be the person, and we say this is so many years old. This dot age is the years. And then we have a for each clause. So whenever we have this curly bracket, then it will be followed by a keyword, and for each is a new keyword. So note that this dot parent is multi-valued. So we could have many of them, and this is the multi-valued result. So like Bill and Mary could be here in the result. This and then vertical bar parent gives you all the labels of the parent. So let's look at the data to see what that is. So here Charlotte and Frederick are the parents, and mother and father are the labels. So you can also refer to these values. Let's go down. Here we only have a father, and here we have even 3 possible values for that. Yeah, so this is these are two sets with multiple values. Then the next part here after the comma is the running variables. So P will be the running variable that is running over this set, and R, the role, is running over this set here. And then the rest that follows the comma here, that is the string that is generated for each element in this set. So it says that P, the person, is the role, like father, mother, etc., of this. So this is the person that has parents. So let's, with this database, let's tell that. And now ask the query, this one. Ask, we can now select this one and ask this query, and that's the result. So Bill is 16 years old, and John is stepfather of Bill, and Charlotte is mother of Bill, and Albert is father of Bill. So that is the result of the for each. We have three values in the set of parents and the role labels here. That's another one, and that's a third one. So note that we only return persons that have at least one person. That is the meaning of the retrieved attribute. If there's no parent, then the object is not an answer of the query. Good. So let's stop that and go to the next one. Next example is recursive queries. So in the case of persons, you have parents, and the parents themselves have parents, and you might want to have a representation of the answer where you have kind of a nesting of the result, depending on how many how many parents a person has. That you see the whole history of a person in the answer representation. It is recursive answers. This one here. Let's make it bigger again. So, well, again, we use here has child, and then we have the example that Adam has 3 children, and Abel has 2, and so forth. So that is kind of a family tree here, incomplete family tree. And then, well, we now recognize that some persons don't have children in the database. So at some point of time we have to stop with the representation, but we would like to return these persons also. So even if they have no children, then they should be in the result set. And that's a difference of inherited attribute versus retrieved attribute. So it's not a mandatory attribute here, but if it's present, it will be returned, even multiple values. So this is not available for all query classes. It's only available for so-called views, but otherwise views work like queries. So now we have an XML-like representation of the answer. Yeah, we return the person and then all the children of the person, which could be multiple. So the children will be under this label here, under this tag. And since it could be multiple, we have a for each loop. So for each has child, we have only one running variable. And now the interesting part is this one here. The children itself is a person and could have more children. So we could have a nesting of person with children. The children are again person, and they may have children. And that is done by asking the person query recursively in the answer format. And we give the variable s here as the name of the person here. So that is to be replaced by this variable s. P is the parameter, the person that we are about to display, and we use the person layout here in the query. So that's the ask query part for recursive answers. So let's tell that and ask the query, person query ask, and we should start with some person. Let's start with Adam and use person layout as a format. And now you see the answer here. So Adam has children, which is Seth and Lot, um, and then Seth has no children, Lot has no children, and Abel has children, and Abraham also has children. So this is a nested representation. There's no indentation here, proper indentation, but it's a nested representation of the answer. Note that for many persons here, there are no children, so we might want to have an answer format where this is not displayed if there is no filler, and I will show that in a minute. So that's nested answer format. And the last one is the thing that repairs this problem with the empty children tag that uses a query to compute the answer format depending on whether a person has a child or not. Recursive answer 1. Good, so the database looks the same. And that also looks the same. The unifies means equal, so we return the person that is given as a parameter here. And now we have a loop that displays all the children, but that's like before, but we don't use a constant answer format, but we use a query to compute the answer format. Let's make it a little bit bigger. So this query, what layout, checks which answer format is suitable for this. And this is just a label that we want to return. So there's a predefined answer format label that returns only the name of the result. So this is the person format for persons that have children, but the children themselves could have no children. So this is the answer format. If a person has no child, then it's just this. So no no children tags here, only the person. And finally, this is the query that returns the layout. So if a person has a child, then it is the complex answer format, person layout children. And if it doesn't have a child, then it is the simple one, this one here on the top. So let's tell that and ask the query again. So start with Adam, and yeah, let's use this default in this case because that will be just the right one. So that is the result. So Adam has children here. Person Said also has children. Let's see. Is there any person without a child? For example, these two here have no children here. So that is the use of this query to compute the answer format. This comment is also generated by the answer format. So we see that this object ends here, and this object here ends here, and Abel ends here. and Cain has no children, and this is the end of Adam. So that's the most complex example that we had so far. Yeah, so this is a introduction to answer formats. I will put the links to the examples in the comments of this video. Thank you, and to the next time.